The first one was 2 and 1 over 10 multiply by 23 over 24 divided by 1 over 6 plus 3 over 5 in brackets. So how am I going to do this? What is the first thing I should do?
Brackets.
Do the brackets first, right? So I'll have 2 and 1 over 10, and you notice, I want you to notice the lines that I'm writing, right? I'm telling the story divided by. You could tell by the second line that I didn't touch anything here and that I'm only dealing with the brackets, right? So the brackets are 6 5s are 30, right? And then I could multiply my cross multiply. So 6 3s are 18 and 5 1s are 5. Is that it? 6 3s are 18?
Yeah.
Right? And 5 1s are 5. And then you add in that there. Right? So that means that now I have 2 and 1 over 10 multiply by 23 over 24 divided by, what is 18 plus 5 is 23 over 30. Nice. So let me ask you something. From this point, right? From this point here, which one should I do first? The multiplication, or should I do the division, or does it not matter?
It doesn't matter.
Right, Caitlin, you agree with that? Right. That is absolutely true, because if I had 10 multiplied by 10 divided by 10, right? What that means, you could say that this 10 is being divided by this 10. So you could write it like this: 10 multiplied by 10 divided by 10. But then this 10 is over 1. So you could do the multiplication of numerators and denominators to get 10 multiplied by 10 divided by 10. 1 multiplied by 10, which is 10. Right? And then because multiplication is commutative, then I can actually say that this 10 is being divided by the 10, and then you're multiplying it by 10. It really doesn't matter. Okay? I could cross this 10, I could cross this 10 off with this 10, or I could cross this 10 off with this 10, or I could multiply both of them to be 100 and then divide it by 10 and get 10 to be my answer. Right? So I hope everybody understands the concept that multiplication and division are really the same thing, and we saw it here with 4 over 2 is equal to 4 times a half. Division is just multiplication by a fraction, right? So at the end of the day, multiplication and division really glues these things together, right? So what I could do is I could switch this to an improper fraction. So 10 2s are 20, that's 21 over 10. Multiply by 23 over 24. And since this is divided, I could put a multiply one time and then invert this. So it'll be 30 over 23. Right? I could see there that the 23s will cancel to give me 1. Right? I could see here that 6 4s are 24. And 6 5s are 30. Yeah. So now it's a much simpler problem here. Right. So then now I could see that, well, all right, this is, can anything else cancel here? Well, look, this 5 over here could cancel with this 10 over here. So now I have 2 times 4, which is 8, and 21 times 1, which is 21. Yeah? So is this the answer that you guys got?
Well, I made a small mistake that's so mad at myself right now.
What mistake was that?
It is the dumbest thing. So the 18 over 15, I thought it was
Oh, so it was a writing mistake. You wrote.
Yeah.
Oh, yeah. What about you, Caitlin? How are you doing with this?
I didn't get the answer. I made a mistake at the very beginning with the 23 over 24. I wrote 25 instead of 23. That's it.
Wow. Yeah, sorry. I think yeah, okay. Well, you guys gotta be careful with that. But I really did write my tree like a 5 there. I mean, I could see it's a tree, but I could tell why it would look like a 5. So I have to be careful about that in the future. Right? So you guys gotta be real careful about what you're writing. Right? And yeah, let me ask you something. What is this as a mixed number? 2, 8 2s are 16 and 5 over 8. Good job. Caitlin, you knew how she got that?
Yeah.
You sure? Yeah? You know how to get from here to here, right?
Yeah.
Alright, I'm just making you sure you're sure you don't want to explain it, right?
I'm good.
Alright, good. Number 2. I'll take number 2 as 5 and 3 over 5 minus 3.5 multiplied by 2 on 3, all divided by 2 and 1/3. So what should I do first here?
I multiply 3.5
Multiply this. So you multiply these two here, right? So you notice I could put it in our brackets, because remember, this number is a negative number, right? This number is a negative number and this number is a positive. When you multiply a negative by a positive, you will get a negative, right? So at the end of the day, your answer is going to be negative. So this is why it doesn't matter if I put these brackets here, because whatever I multiply and I get as the answer, this negative sign over here will make it negative, right? So you could say that I cannot put in my own brackets, but you have to imagine where the brackets would be, right? So I'm going to say that that is equal to, let's change everything to improper one time. 5 5s are 25 and 3 is 28. First of all, did everybody write down this question correct?
Yeah.
All right, Caitlin?
Yeah.
All right, just making sure. 28 over 5 minus, and we'll just do the conversions. 3 2s are 6 and 1 is 7 over 2. Multiply by 2 over 3. Divided by 2 3s are 6 and 1 is 7 over 3. So you could see clearly that from this step to this step, all I did was change everything to improper fractions. Whenever you're doing work for CSEC, you must make sure that each step is clear, right? Because this will make it easy for your examiner. Right? And if you're making life easy for the man that marking your paper, then he will mark you easy. Right? If you're making life hard for him, then he will mark you hard. Right? So we could do the brackets first. So 28 over 5. Somebody mic on. Right? Minus in the brackets here, 2 3s are 6, 7 2s are 14. And that is divided by 7 and 3. So now what do we do? What should we do now? Right, so minus the numerator. Now all of this is being divided by 7 on 3, and so would you agree that I could put the 28 on 5 minus 14 on 6? All of this is being divided by the 7 on 3. So I could invert and multiply one time, eh?
Yeah.
Yes, so I technically can do that. And now I'm still doing the same thing. I'm still going to work out inside the brackets first, right? So inside the brackets are going to give me 6 5s are 30. And then, ooh, we have some big numbers here. Where's 5 times 14? 70. And then 28 times 6 is 168. So 168, and there's a minus there, right? And I'm making sure, and I'm putting back the rest of the problem because I must be continuous with the story. Yeah? I must be continuous with the story. So 168 minus 70 is 98 over 30. Multiply by 3 over 7. Well, now I could see that this 3 could go into this 30. So I'll get 98 over 10 multiplied by 1 over 7, which is 98 over 70. You all got this answer? No, what was the mistake you made? Did you get 98 over 30 inside of this brackets for this?
No.
What did you get?
When I was working out 3 multiplications, I left the 5 and 2 5 as the next number, and I was supposed to on that.
Sorry. What? When you was working out this multiplication, what happened?
I left the sign with 3 as the next number, and I was focusing and stuff the brackets, and I get the answer.
You get this answer here? The stuff in the brackets is this, right? I changed it to improper fractions first, and then when I worked it out, I got 14 on 6. 7 2s are 14, 2 3s are 6. Caitlin, you got up to here?
Yeah.
Alright. Did you get the final answer, Caitlin?
No.
Okay. So I'll go ahead and give all you more of these then. So Scotia, you did not get 14 on 6.
Well, I got the answer, and I got 7 over 3, and I changed that back to a mixed number.
You got 7 over 3 and you changed it back to a mixed number, okay.
And I realized that it might sound dumb, I don't know, but I realized that it was 2 and a third, so I just kind of managed to consider.
Right. And it's really important for me to see what you guys did, because I want to know what it is you minus the 2 from. You minus this 2 and a third that was underneath here, but what you minus it from, because this is a divisor, it's dividing.
Well, I divided by the other 2 and 1/3, and yeah.
You have a 2 and 1/3 somewhere else.
The answer that I get from the multiplication.
But the multiplication is 14 over 6.
I changed it back to a mixed number.
And that as a mixed number is what?
2 and 2 over 6.
Which is 2 and a third.
Yeah.
Right. So what you had was let me see if I got you correct, right? You had the 28 over 5 minus 2 and a third divided by... Sorry?
I left it, didn't change the 5 over 3.
Right, so it's 5 and 3/5, right?
Yeah.
Minus 2 and a third divided by 2 and a third. And what did you do then? Because so far, you're not wrong. So far, you're not wrong. So what you do next?
I divided the 2 and a third by the negative 2 and a third, and I got minus 1.
So you went this divided by this.
Yeah.
No. Why? Because remember how I was just saying 10 multiplied by 10 all divided by 10 is the same. You could just cancel this off with this right? Because that is the same as 10 multiplied by 10 over 10 or 10 divided by 10 multiplied by 10, right? It's all the same. So you could do that because it's a multiplication over here. Yeah? So with multiplication and division, you could do that. And you see, this is why it's so important for me to see the mistakes you're making. Because this is a common error that people just make. But when you have a situation like this, 3 plus 5 all over 7. All right, actually no, let me put 3 plus 5 all over 5. Right? Now 3 plus 5 all over 5. You know 5 plus 3 is 8, right? And that's 8 over 5, which is 1 3/5, right?
Yeah.
Right. Well, 3 plus 5, both of them divided by 5. Remember that addition does not glue the numbers together. Addition does separate the numbers. Right? So you have to think about both of these numbers as being separate. So therefore, the 3 is being divided by the 5, as well as the 5 is being divided by the 5. So you can't just go and cancel 5 and 5 because you're not getting this answer, you're going to get 3, right? Yeah. So no, that can't work like that. You have to remember that both of them are being divided by 5. So that means that the 3 is being divided by the 5 and the 5 is being divided by the 5. See what's going on there?
Yeah.
So now I have 3 over 5 plus 1, which is 1 3/5. Yeah? Now this, Scotia, and I are really happy that I took the time to ask you, because this is the thing that's so important. These are the mistakes that you all will make when you reach algebra. So we had to iron out these mistakes from now. So really and truly, you can't cancel out these. Really and truly, you was correct up to here. But really and truly, it would have been 5 and 3 on 5 divided by 2 1/3 minus 2 1/3 divided by 2 1/3, eh? Right. Now this would have cancelled to give you 1. So therefore you would have ended up with this. Now let me create some space here. Oops. Yeah, where are you? Yeah. So now you would have ended up with 5. Oh, come on. 5 and 3 over 5 divided by 2 1/3 minus 1. And now you would have to improper fractions this thing in order to divide it, right? So now you would have 5 5s are 25 and 3 is 28 over 5 divided by 2 3s are 6 and 1 is 7 over 3 minus the 1. Right? So now you could work this as 28 over 5 multiplied by 3 over 7. And all of that would have been minus 1. Right? Working with me so far?
Yeah.
Right? So now you would have go to say, well, alright, nothing could cancel there. Wait, 7 could go into 28, 7 by 4, eh? Right. So 7 into 1. Right. So 4 3s are 12 all over 5. 12 over 5 minus 1. Right? 12 over 5 minus 1 is what? This is 12 over 5 is an improper fraction. So that's 2, right? 2 and what?
2 over 5.
2 and 2 over 5?
Yeah.
Minus 1. And we'll get the answer of 1 and 2 over 5, eh? Right. So we didn't get 1 and 2 over 5 here though. We get 98 over 70, but that is because 98 over 70, well, 70 will go into 98 one time, right? and you will have 28 over 70 remaining, right? And then this 28 over 70 would I be able to reduce, because 28 over 70, you know, 28 over 70 would have gave the 2 over 5. You know, can 7 go into 28?
Yeah,
4, right? So 7 4 is a 28, right? So if you had reduced this, you would have gotten the 2 over 5, 1 and 2 over 5, 1 and 2 over 5. This way actually is an easier way because you didn't have to work with such big numbers. Right? These are so I'm glad that we do this, because this is 2 different ways of doing it. Did you guys write down the 2 different ways?
Yeah.
Right? Now,
Yeah.
Caitlin, where in this did you go wrong?
When I get before 16, I reversed it back to a mixed number and then I cancelled off the 62. Basically, what's social?
Wow. Well, I am super happy that we're doing this then. Really happy that we are doing this. So, this is wonderful. This is wonderful. Okay, good. I'm glad that we did this. Right. So, let's look at... So, let me just make a little bit of room here. You know how plenty of both you did you guys write down both of these methods?
Yeah.
Caitlin?
Yeah.
I hope so. I hope you guys writing down everything that I am. Because I'm not writing to decorate the board. Right? So next one. Number 3. 5 and 3 over 5 plus 2 and 1 over 5 divided by 4 minus 1 and 1 over 5. What do we do here first? How do we approach this one?
I plus 3, 5 and 2, 5 2, I 1
Yes. So what you're trying to say is you're working the numerator first, and then you're working the denominator. Eh? Yeah?
Yeah, exactly.
Right. That's correct. But doesn't BODMAS say to do the division first?
Yeah, I was thinking about that, right.
Right. So BODMAS does say to do the division first, but guess what? Really and truly, BODMAS does say to do the brackets first. And if I wanted to, I could go and put brackets here, because that's not going to be wrong. And then put brackets here. That's not going to be wrong. Yeah? So sometimes you have to be able to see where those brackets are. Yeah? So it actually have brackets there, invisible brackets. Yeah? So yes, you're right. You do your numerator and your denominator first. Now, how did you do the numerator? Right, and you went through all of that madness. But guess what? You didn't have to do that because they have the same thing. Eh? So imagine now if I had, remember we were talking about it, 3 over 4 plus 1 over 4. And you don't have to do any of the LCM business. Once it have the same denominator, you could just keep it over 4. And you could go 3 plus 1 is 4, eh? Right. So it's the same thing here, right? Because they are of the same denominators, means that I could just literally add my whole numbers. 5 and 2 is 7, and then add the 3/5 to the 1/5 to give me 4/5. And is this the answer you got for the top there? Seven fives are 35, 36, 37, 38, 39 over 5. Alright, yeah. Now, at the same time, this bottom one, a lot of you guys would have probably wanted to change this to an improper fraction, and
Yeah.
and then put this as 4/1, and but you don't really have to do that. You could use reasoning. You could say, well, if I had a pizza with 4 slices and Caitlin teeth 1, then I'm going to have 3 slices, and so what if Caitlin teeth more than 1? She teeth 1 1/5. So I no longer have 3 slices, I now have 2 slices and then 4/5 of the 3rd slice that she teeth. And
Yeah.
right. So you could actually use reasoning to figure out these things. So this answer here is 2 4/5. Right? And if you had used your improper fractions, 4/1 minus 5 ones are 5 and 1 is 6/5, that is fine, because you'll get 5 there. This will be 6, 5 4s are 20. So 20 minus 6 is 14/5, which is 2 4/5. Yeah? Everybody okay so far? Caitlin, you're getting this correct so far? Not really. Where did you go wrong so far? The first step, you mean adding these two?
I didn't add them once already.
What did you do?
I made the same mistake I did in the previous one when I divided it from 13 to 4.
Oh, you just started cancel off like you're mad.
Yep.
Nah, you can't do damn thing. You could only do that if this was a multiply and if this was a multiply. If that was a multiply and that was a multiply, then you could have started just cancel everybody from a side, right? Because remember, then everybody would have been 1 unit. If it was 5 and 3/5 multiplied by 2 and 1/5, divided by 4 multiplied by 1 and 1/5, that would have been the same as 5 and 3/5 multiplied by 2 and 1/5 divided by 4 multiplied by 1 and 1/5, right? And now you could have cancelled anything with anything with anything. The same thing as the example we were doing just now. Yeah. So that definitely works with multiplication if you had multiplies right through. But that addition there, that messes up everybody, right? So you see here that you kind of had to add them, right? So what are the improper fractions you got on top of here? 7 5s are 35, that's 39/5. Scotia.
Oh, yeah.
And 5 2s are 10, that's 14/5. Right? And now we could invert and multiply 39/5 multiplied by 5/14, and the answer is 39/14. And as an improper fraction, what would this be? 2
and 11/14.
and 11/14.
Not that one.
Right, good job. And that's okay, Caitlin, for making the mistakes. I'm glad. I'm really, really happy. I believe that we should go to school to get things wrong. I believe that we should go to school to fail. Not because we want to fail, but you learn so much more from when you get things wrong, right? So I'm really, really happy that you guys made the mistakes that you are making, because it shows me exactly what to focus on. Yeah. So number 4, 5/9. 5/9 minus 7/15 divided by 1 minus 5/9 times 7/15. Now, Caitlin, did you go and start cancelling off stuff again?
No, I didn't, surprisingly.
Right, so you didn't cancel 5/9 with 5/9?
No,
Why you didn't do it this time?
I don't know.
I wish all you had continuity in all your errors, you know. It would be nice. It would be nice. So what to do first here then? That's not bad. Did you put a little brackets and leave the minus sign right there?
Yeah.
Alright, good. So 5 over 9 times 7 over 15. So we'll get 1 minus, well, 5 could go into 15 by 3. So that is 7. And 9 3s are 27.
Yeah.
Is that what you got?
Yeah.
Right. And then well, we're leaving the top how it is for now. 5 over 9 minus 7 on 15. So what did you do next? Now is when you start to cancel off things? Alright. When?
Minus 3, 5 over 9, that is 17. 7 over 15.
Right. So we we could see here that we have no choice but to go 9 times 15. Right? Which is 135. Now, even though there is a LCM there, but we don't really have to study what the LCM is, because remember 3 could go into 9 and 3 could go into 15, right?
Yeah, I thought about that, but I was like, no.
Yeah. Literally, the generalization that I showed you works for everything. So you don't even have to think about anything else, right? And then over 35, and then I go in 5 times 15, which is 75, minus 7 times 9, which is 63. And this is divided by 1 minus 7 over 27. Right? So this now is equal to 75 minus 63 is 12 over 135. Right? And that is being divided by that is being divided by 7. So what is this? We had to work this out. How do we work this out? How did you guys work this out?
107 over 27.
Did you go 1 over 1 minus 7 over 27?
No, I did 27 over 27.
Alright. Caitlin, which one did you use? 1 over 1, right? Well, both of them are correct. But you could think about 1 as 27 over 27 minus 7 over 27, which will give you 20 over 27. Is that what you got, Caitlin?
Yeah.
Alright, good. So at least all of we on the same page with this question here. 20 over 27. So now we could invert and multiply 12 over 135 multiply by 27 over 20. Right? Can 135 go into 27? Yes, it can. It could go into it 5 times. Right? Can 12 go into 20? Well, 12 over 20, it could be 5 4s are 20 and 3 4s are 12. Right? So now we have 3 times 1 is 3 and 5 5s are 25. Is that what you guys got?
I forgot to do that.
You forgot to reduce it. So what did you?
Yeah,
So you literally multiplied out these guys.
I reduced to 12 and 135 before I start multiplying.
But 12 that could reduce? Oh, 4 over 45.
Yeah.
Oh, okay. Alright.
So I get 9 over 75.
9 over 75. That's your final answer.
Yeah, I didn't reduce.
Alright, but that's fine. That's fine. Once it's the same thing. Caitlin, what did you get?
I got the 25.
Alright, good job. So both of you guys got one question correct. Right? So this is unacceptable. So we're going. Okay, good. But still, this is unacceptable. So what I'm going to do is I'm going to give you guys 4 more of the same questions now that you have an idea of what to do. But let me find some really tough ones, right? Just now. 1. For 8 more minutes now. So let's get started with this first one. What's the first step? Right, that's always a safe way to go. So 5 2s are 10, 12 over 5. Multiplied by 1 4 is 4. 5 6 7 over 4. Divided by 7 over 4 times 12 over 5. And what now? Right, you cancel everything because this is this multiplied, so you can think about this as 1 unit. This is multiplied, you can think about this as 1 unit, right? If you want to generalize, this is kind of like A times B all over B times A. So yes, in this case, because it's just multiplication, the B's will cancel and the A's will cancel. So this will cancel with this will cancel with this, and you will get 1. You okay with that, Caitlin? Lovely, very good. So let's check number 2 here. What's the strategy for this one? Work out the brackets first, and then I will work out this multiplication after, and then see where we go from there, right? So in the brackets now, well, let me start converting things one time to improper, right? So 8 times 13 is 104 plus 7, which is 111 over 13. You all got that for this one? I don't know if you actually changed anything to mix numbers there, but we'll see, right? Plus, now 4 minus 2 1/3. 4 minus 2 is 2. And then if I minus a next third, I would have 1 2/3. Is that what you got for this one? Five on 3. Anybody?
Wait, hang on. Yes.
Caitlin?
Yeah.
You sure?
Yeah, I do it backwards.
5 1 3, right? Well, I guess all you do write out all your statements like how I write it out, step by step, right? So if you want, you could have done 4 over 1 minus 2 3s are 6 and 1 is 7 over 3, and then you could have do the thing with 3, and then 4 3s are 12 minus 7, which is 5 over 3. Is that what you guys did?
Yeah.
Alright, good. But you see, I didn't do that. I used reason. I just said, well, 4 minus 2 is 2, and then if I minus another third, I would have 1 and 2/3 left, which is 5 1 3. And now we could do this guy here. So this guy is 27 times 3 is 81 plus 1 is 82 over 27 multiplied by 3 over 10. You all got this 82 over 27?
Yeah.
Alright. 1, 7, 3's. Wait. Can 3 go into 27? No? Yes?
Yeah. There's 9.
9, yes. Sorry, our teaching says 9 this morning. Right? And 9 could go into 82? No, 9 could go into 81. Right?
Yeah.
So what we ended up here is with 82 over 90. Right, good job. So, did you all get a negative answer for this? 82 over 90 minus 2. Is that what you got for the denominator?
290?
Yeah, minus 2. Caitlin, we good so far?
Yeah.
You sure you got 82 over 90?
Yeah.
Alright. So now what? Caitlin, you start crossing things off here?
No.
Alright, what do we do now?
Sorry?
Add the numerator and the denominator. So I could go 13 times 3 is 39. So that is equal to, let's do the numerator first. 39. 13 times 3 is 39. And then I go in 13 times 5 is 65. Plus 111 times 3 is 333. Right? So 333 plus 65 over 39. That is my numerator. And my denominator, right, is going to be, this is 82 over 90 minus 2. Now the reason why, Caitlin, was your final answer a negative answer?
No.
Scotia, was your final answer a negative answer?
No.
Alright, so here's why I asked that question. Is this a proper fraction?
No. But, yeah.
Absolutely it is. And a proper fraction is always less than 1, isn't it?
Mm-hmm.
So imagine this was 90 over 90. That would be 1 minus 2. Isn't that a negative?
Yeah.
Well, this is even less than 1, isn't it?
Mm-hmm.
So your answer is going to become negative. Obviously 2 is larger, right? So if I wanted to, I could say that I have two ways I could work this out. Isn't 1 90 over 90?
Yeah.
Right. So 2 will be 90. 2 will be 180 over 90. Eh?
Mm-hmm.
Right? So now I could just minus 82 minus 180 and I will get negative 98 over 90. Is that what you guys got? I guess not. What did you get for that denominator?
Oh, wait. Wait, yeah, I was looking at different parts of the so I got a negative answer.
Alright, good. Well, your final answer should be negative by the way. Right? Caitlin, did you get that for your denominator?
I have the 98 over 90. I just forgot the minus sign.
But you got 98 over 90?
Yeah.
Alright, well, I don't know how you could forget the minus sign because, you know, you have to be careful because that will get your whole answer wrong. But let's see, right? So this numerator, 333 plus 65, that'll be 398 all over 39 multiply by negative 90 over 98. Yeah? So can anything cross off there? 398 divided by 98? No. Alright, so let me just multiply out 398 times 90. It's a big number, 35,820. I just multiply that there. I'll put the negative sign here. Divided by 39 multiplied by 98, which is 3,822. And can one go into the other? 35,820 over 3,822. You're supposed to get, well, the answer that the calculator gave me here, well, is a negative 9 and 237 all over 637. Y'all get that?
No.
What did you get?
I'm getting another mistake.
But what was the mistake you made?
Well, after I got the 90 to negative 98 over 90, I changed that to this number and I kind of forgot about the numerator and
Okay.
Yeah.
What about you, Caitlin? You got this?
Surprisingly, yes.
What? So Caitlin beaten back Scotia this time. But Scotia, you said you changed 90 over 98 to a mixed number?
98.
Or 98 over 90? You mean as it was in the denominator here? Oh, okay. But that I don't understand why that would be wrong though. Changing it to a mixed number is okay.
I forgot the number.
I see. Okay. Alright, but you know what you did wrong. You understand everything I'm doing here?
Yeah.
Alright, you sure?
Mm-hmm.
Right. Number 3. Let's go to red this time. I wish they had different colors. Ooh, they have lots of colors. Let me go purple. Yes, purple. Aha! Well, it doesn't look that great. Let's see what, I'll go purple. Okay, so what to do here first?
Change all down to the improper fraction.
That is a good strategy. So 9 times 7 is 63 and 3 is 66 over 7 minus 5 times 14 is 70 and that'll be 71 over 14. That's interesting. Minus 2 times 21 is 42. 42. Wait, no, I do not say 21. 42 and 5 is 47. Yeah?
Yeah.
Right. What next?
I did 2 of them at a time. Like minus the 66
These 2
over
and then
7.
minus these 2. Yeah?
Oh, I put brackets on 66 minus, over.
You put brackets there?
Yeah.
Okay, and then you work out that first.
Uh-huh.
But don't you notice something?
Yeah, I did. It's bracket.
What did you notice?
That's 7, 14, and 21 and stuff.
Yeah. So if this was 66 over 7, this would be, well, 2. Wait, no. It'll be 71 all over 7 times a half, eh? And? Hello?
What?
Alright, I converted this to this. Do you agree with that?
Yeah.
Right? Also, I could say that this would be a third multiplied by 47 over 7, eh?
Mm-hmm.
Right. That is one way to work it. Is there any other way to work it in terms of, could I just pull something out of all of them?
I don't know.
Maybe I could say, what if I pull out 1 over 7? So that'll be what? 66 over 1, and minus 71 over 2, and
Yeah.
minus 47 over 3. Yeah, so it has many different ways that we can work this, and I wanted you guys to see that you guys could pull out a factor and a multiple and all of them kind of madness, you understand? Right. So, but what you did, Scotia, was absolutely correct. You could do it the same way you could just take 2 at a time, and that is no problem at all, right? So Caitlin, what did you do for this question? Hello?
Sorry, I had brackets of the first two.
And you undo that.
And yeah.
Right, so let's just do it like that, right? So we could take the denominator to be 14, being the lowest common multiple, right?
Yeah.
But you could have multiplied it out 7 times 14. Guys, did you multiply it out or did you use 14? Okay, well let's multiply it out. 7 times 14 is 98. You'll get the same answer in the end anyway, right? 7 times 71 is equal to 497 on this side, minus 66 times 14 is equal to 924 on this side, right? So that is in the brackets, minus 47 on 21. So that is 924 minus 497, which is 427 over 98 minus 47 over 21, and that will give us 427. Did you all reduce 427 over 98? No, you leave it just so?
Yeah.
You must always reduce your fractions, but we'll see if you get the final answer. But the reduction of that is 4 and 5 over 14. So you see we get back to 14. Yeah? So 4 and 5 over 14 minus 47 over 21. Let's change that to improper fraction. So 4 times 14 is 56. 56 plus 5 is 61. So this is 61 over 14 minus 47, is it? Over 21. Now we could use the 21 here because is a common multiple, or we could do the whole multiplication thing. So let's do the whole multiplication thing. 14 times 21 is equal to 294, right? And now we could cross multiply. 61 times 21 is equal to 1281 minus 47 times 14 is equal to 658, and therefore that is 1281 minus 658 is equal to 623 over 294. And can that be reduced? 623 over 294. It could be reduced. Did you end up with this answer?
No.
What's the answer you get?
4,261 over 2,050. Yeah, that's it.
Just now, the final answer here is 2 and 5 over 42, right? But what was the answer you got? Tell me again. What's the numerator?
4,261 over 2,058.
Yeah, same thing.
Okay.
So you did get the correct answer, but please reduce it. Do you guys know how to use a calculator to reduce?
Yeah, okay.
You think so? Your calculator should have a button A, B over C. You all know that button?
Yeah.
Right. So if you want to reduce something, you could just put like 623, and you press that button, and then you go 294, and that will show you 623. 623. It will show up like this over 294, and then you just press enter. And then you just press enter, and it will actually reduce it. What it will tell you is it'll show you 2, it'll show you this 542. So what that means, when you see 3 of them, that means that this is a mixed number. So you have 2 and 5 over 42. Did you guys know this?
Yeah, but I really still use a circle.
Yes, but you can, especially when you have annoying things like that to reduce, you can definitely use that to reduce it, right? Right, so right, so this one. So wait, did you get the answer for that, Scotia?
Yeah.
Oh yeah?
Mm-hmm.
All right, lovely, lovely. So we're on a roll here now. So obviously we're gonna work the brackets first. 6 4s are 24 and 5 is 29 over 6 minus 3 1s are 3 4 5 over 3. And we put in that divided by 3 1s are 3 and 1 is 4 over 3. Right? So now we could say 6 3s are 18. Or we could actually just use 6. It doesn't really matter because 6 is the lowest common multiple of the both of them. But since we stick into the generalization, we'll just do it the one way, right? But we could definitely use the 6. So 6 3s are 18, right? Am I saying that correct? 6 times 3? Yeah, I had to use my calculator to check it out, right? 29 times 3 is 87. Minus 6 5s are 30. And this is all being multiplied by 3 over 4. You get what I'm saying there? Yeah? Right? I don't have to do it just yet. So let me keep working inside the fractions first. So 87 is inside the bracket, sorry. That's 57 all over 18 multiplied by 3 all over 4. Right? Can 18 go into 3? Yes. This is 6. Can 57 go into 4? I don't think so. Right? So I'll probably end up with 57 all over 24. 6 4s are 24. Right? And so 57 over 24 gives me 2 and 3 over 8. How will you feel about that? Did you all get this answer?
No.
What was the answer you got?
3 and 11 over 12.
3 and 11 over 12. How did you get Caitlin, what did you get?
I got 2 and 3 over 8.
Alright, lovely. How did you get 3 and 11 over 12, young lady? What was the difference? What did you do? Did you do up to here 87 minus 30?
No, I've moved the bracket.
You move the brackets?
Yeah.
How you can move the brackets? So what, you do the divide first?
Uh-huh.
Child, BODMAS, you have to do the brackets first. And?
No, I've moved the bracket to divide.
Yeah, but you move the brackets so you divide this by this. You can't do that. You know why? What do these brackets mean? These brackets mean that this entire thing inside the brackets is being divided by 1 1/3. You understand?
Mm-hmm.
Right? So BODMAS, if it is that I have 3 minus 5 divided by 2, I can remove the brackets and say 5 divided by 2. And?
Yeah.
Right? So you understand what you did wrong there?
Yeah.
Right. So you get it wrong from the very beginning. Right? That's okay though. As I say, I'm glad if we get things wrong. Getting things wrong is good. It teaches us the mistakes that we make. It teaches us what we need to improve on, right? Well, this one looks pretty easy. 8 trees are 24. 1 is 25 over 3. Multiply by 5 trees are 15. And 3 is 18 over 5. Well, that looking like it's working out pretty easy. 2 1s are 2 and 1 is 3 over 2. Multiply by 2 trees are 6, 7, 8 over 3. Wow. So now we work in the numerator. We can see that 3 into 3 is 1. 6 trees are 18. You see 5 into 5 is 1. Oops, 1. And 5 5s are 25. So 6 5s are 30. We actually ended up with a numerator of 30. And then the denominator, 2 into 2 is 1. 2 into 8 is 4. 3 into 3 is 1. So we just get 30 over 4. And 30 over 4 is 7.5. So you got this for this one?
Yeah.
That's Caitlin or Scotia?
Scotia.
And Caitlin?
Yeah, I got it.
Alright, good. So Caitlin, it sounds like you outperformed Scotia in this exercise. How much you get out of the 5?
I think 5.
Wow. And Scotia, how much you get?
3.
But that's good. I didn't ask you to shame you. No, I didn't ask you to shame you at all. Right? Listen, I am happy. I am really, really happy. Right? Because I got to see what your weaknesses are. Yeah? We could see that you guys have weaknesses with BODMAS and weaknesses with fraction. Right? Both of you. So obviously, when you reach algebra level, it's obvious why you guys don't like algebra. Right? Because your problem was never with algebra. Your problem was with this. Your problems was with BODMAS and fraction. Yeah? So I am really, really happy that we did these questions today, that we got some exercises, because it gets to reveal our weaknesses, and that is what we want. We want to reveal our weaknesses. We don't want to hide our weaknesses. When you hide the weaknesses, that means you're not dealing with it. Yeah? We want to deal with it. So reveal the weaknesses and deal with it and let them become strengths. So I will not give you any homework today. The next class is going to be on Tuesday. Right? So what you guys are going to do is on Tuesday, I'm going to give you a couple more of these questions. Yeah? Just to make to sharpen you up a little bit on it, BODMAS with fractions. Right? But also we're going to go back to the first class, how we started with 3 plus 4 equals 7. Well, we're going to go back to that first class. We're going to look over all of those principles, but we're going to add x and see how x is going to work out inside of it. Yeah? So, anybody have any questions from today?
No.
It was today helpful?
Yeah.
Caitlin, how about you? Was today helpful to you?
Very helpful.
Alright. And I'm really, really happy because both of you guys used to complain to me about algebra and how algebra hard. But as you can see, it's not algebra that hard. Once you could do this, algebra is just the same thing, but with some letters inside of it. That is all. Yeah? So I'll see you all on Tuesday. Yeah?
Yep.
Take it easy, no homework. Yay!
Bye, guys.
Alright, good.
Bye.